Downey syndrome. And how do you identify Downey syndrome? You can identify Downey syndrome by the child having a very large palm with a single simian crease or the transverse crease. You can see it is very prominent and you can clearly see it. So let me proceed to the next slide. So here we're having two children having trisomy 18 and trisomy 13. As you can see, trisomy, it arises by an addition of an X chromosome. So both of these two are having trisomy but of different kinds. And now this is Turner syndrome. Turner syndrome, it occurs where there is partial loss or complete absence of an X chromosome. Characteristic features: in the first slide we can see that the child has a malformed ear, the child has a very short neck, and in the second and third picture we're seeing that the child has big or enlarged hand and foot, and it arises due to leaf edema. Then on the fourth, that is when we are seeing that the child has a webbed neck. The webbed neck, together with the nipples being pushed to the periphery, being widely spaced and leaving a very big space in between them, it occurs due to leaf edema still. Let me proceed. This is Angelman's syndrome. Angelman's syndrome, just like Prader's syndrome, they share some similarity. The similarity comes in, they are both microdeletions on the X chromosome, but the difference is that Angelman's syndrome is on the maternal side and Prader's syndrome is on the paternal side. As you can see, this is microdeletion on chromosome 15 on the paternal side, and this is microdeletion on chromosome 15 on maternal chromosome, that is maternal side. Now we're going to see conjoined twins. Conjoined twins, this birth defect is very common in frogs, where you can find that you're seeing a two-headed tadpole. So here we're seeing conjoined twins. But this kind of conjoined twins, when you go deeper, we'll call it dicephalous, being that the embryo is two-headed. It occurs due to overexpression of a given gene. That gene is called Kusekostroke-D. It is being overexpressed within the humans. So you find that you're going to give birth to a dicephalous or a conjoined twin or two-headed. And now this is what we call chordodysgenesis or serenomelia. Chordodysgenesis, it arises, you're seeing that the fetus or the child has the two limbs being fused. He actually looks like a mermaid. So what happens is that we have the mesoderm in the lumbosacral region getting lost. When it gets lost, we have the limb buds getting fused. So if the limb buds specifically get fused, because the limbs arise from the limb buds, when they get fused, so you're going to have the limbs also fused. That is when you're going to have a mermaid appearance. Now this is another birth defect known as sacrococcygeal teratoma. Sacrococcygeal teratoma arises when the remnants of the primitive streak develop and form what you call the tumor cells. Those tumor cells are the ones that are going to form tissues. The tissues are going they are malignant, in that they're going to cause some swelling, some kind of a tumor below. Now you're seeing, as per this child, the tumor is developing in between the two legs. So this is sacrococcygeal teratoma. The next slide we have, it's a defect that arises from, it's a neurotube defect, NTDs. As you're having during the process of neurulation, while you're having the neural folds approaching each other and fused across the midline, there is formation of what we call a neural pore, the cranial and the caudal posterior and anterior neural pore. So you find that when the caudal neural pore fails to close, you're going to have spina bifida. Spina bifida is within the second and third image. Now for the first image, it's known as anencephaly, where the cranial neural pore fails to close. So those are the two. And we're saying that spina bifida expresses itself. It has more chances. Most of the cases, it's spina bifida. Let me continue. Then we have capillary hemangiomas. But let me first proceed on to, it's not the, we're going to go through capillary hemangiomas first. Hold on a bit. We'll proceed to the birth defects of the ventral body wall, the body wall failing to close. So what happens when the ventral body wall fails to close? For the first image, you're having an abnormality known as ectopia cordis. Ectopia cordis arises when the ventral body wall, the lateral folds fail to approach each other along the midline to fuse. So what happens? You're going to see that the heart lies outside, and you're going to see a big cleft in between the thorax. And for picture number 2, that is when you're having, that is gastroschisis. That is when the intestines, the intestinal loops, they move out. They cause hyalination in the umbilicus, that is on the right side. Then for the third image, that is bladder atrophy. The bladder is completely out. That is when the lateral body wall folds fail to approach each other along the midline, that is in the pelvic region. When they fail to approach each other, that is when the bladder is going to get out. So we also have glaucodystrophy, glaucoextrophy. Glaucoextrophy arises when still the body wall fails to close, but it is within the pelvic region. So you're going to have some part, you're going to have the some part of the rectum together with the bladder and the anal canal being completely exposed. And now, this is what we call omphalocele. Omphalocele, we're having the lobes of the bowel hyalinating into the umbilical cord. Now these are fetal hydrops, just accumulation of tissue of fluid within the fetal tissues. And now this is these are other abnormalities of another category caused by amniotic bands. Amniotic bands, we're seeing in image number 1 there is limb constriction. Image number 2 there is toe amputation, toe constriction. Yeah, the toe is constricted, as you can see. Now for this slide we're having fetal papyruses, whereby in slide A, that is in image B, we're having one twin is larger than the other. So the other one has been very much compressed and mummified in that it is nearer to getting to dying. Then that is per image A. Then per image B, that is when you're gonna have monozygotic twin transfusion syndrome. Monozygotic twin transfusion syndrome, we have the placental vesicular anastomosis. They cause what we call unbalanced blood flow to the two twins. So you're going to see that one of them is larger and the other one is smaller. So, yeah, these are conjoined twins still. The dicephalus, you remember, and craniopagus, where they're joined by two heads. These are still amniotic bands. Cleft lip in image 1, toe amputation B, and together with the finger amputations. Then these are abnormal positioning of lower leg. It's actually club feet. It's a deformation still. And this is for comelia, where long bones fail to develop. You're having those short hands, as you can see.